Hello everyone, my name is Rahul and welcome to my channel DevOps Force. So today we are going to start a series of video on topic Terraform so that you will be able to understand at the end of the series that how Terraform is used, why it is used, when it is used, and also what was the need of creating Terraform as a tool. So this series will be helpful for a freshie or a mid-level expert or a senior expert because we are going to deep dive into the topic or the core concepts of Terraform from beginner to advanced, and we will cover each and everything which is present in the official documentation so that we do not miss anything. And this is the video for 2026 which is going to have each and every topic covered. So these are some of the topics which we are going to cover as you can see on your screen. First of all, we will understand what is IAC and the fundamental. Then we will understand the core principles over there. The next topic is Terraform workflow, where we have core concepts like init, plan, apply, destroy. We will understand how Terraform configuration language is used using the resource blocks or data types, input variables, etc. Then we will understand Terraform expressions and functions, loops and dynamic infrastructure, the Terraform dependency graph, either it is implicit dependencies or explicit dependencies. We will understand the core engine, which is the Terraform state, and the most important topic, where we will also understand some essential state commands. We will configure the remote state and backend. Then we will understand what is code reusability in Terraform, which can also be called modules. The environment management used at enterprise level and very beneficial to understand. Terraform security, how to secure your Terraform and your credentials, the lifecycle rules, and Terraform provisioners. This can be an optional topic, but yeah, it is very important to understand because we are going to cover each and everything in this series. We have Terraform testing and validation. We have some debugging and troubleshooting steps where we will cover the video on how to debug or troubleshoot your issues in Terraform and performance and scaling. So when this video or the series of these videos will be over, I'll be coming up with the next playlist which will have real Terraform projects used in enterprise level, or you can say in the major IT companies, and it will be a deep down to all the concepts which we have covered in this video, and we will be understanding each and everything using the real world projects. And one more playlist I am planning to do. Let's see if it is feasible, then we will create that as well, where I will cover advanced topics of Terraform and advanced debugging and troubleshooting issues which are actually being faced into the real world, or you can say enterprise level. So let's just quickly start and understand Terraform. So before that, you have a very important step to do, which is you have prerequisites which you should definitely get it covered. So the first is you should have the knowledge of cloud. So cloud knowledge, it can be AWS, it can be Azure, GCP, anything. Next thing is you should have Terraform installed. So I'm not covering this part because there are various videos on YouTube you can find out, or you have the official documentation as well how you can install your Terraform. Or else what I can do is I will add a installation.md file into my repository where I will explain, or I can add those documentation where you can follow up and create or install the Terraform, right? The next is you should have AWS CLI installed, right? Because we are going and learn AWS. So this is very important. Next is AWS account. So you should have these four things as a prerequisite, and then we are good to go. So moving on to what is Terraform. So before that, you must have heard that Terraform is called IAC, right? And it stands for Infrastructure as Code. So from where does the Terraform, so what was the need to create this tool, Terraform, and how does it started? So let's understand this in a simple way, where initially what used to happen is the developers or the DevOps engineers or the platform engineers or the SRE used to create the or provision the resources manually. So in that case, there were thousands of projects used in enterprise level, and it was very difficult to manage all those thousand projects manually, provision your resources, and there were high chances of creating an error or the manual process was slow as well. So there was a gap in the market, and the cloud providers clearly understood that. So what they did, so let's take an example of AWS. So the developers of AWS written a code to create CFT, which is Cloud Formation Template. And Cloud Formation Template is a template where you have code written over here. It can be written in JSON or it can be written in YAML. And applying this Cloud Formation Template, you will be able to provision your resources. So for example, you have multiple resources like VPC or databases or networks. You will write everything here in this template, and you will create an API call from your provider plugin, and then it will create the infrastructure. So this is a very good way to introduce infrastructure as code, and it was very helpful to the developers. But the problem is you have multiple cloud in the market, and each and everyone is using it differently. So maybe an organization must be using AWS, the next would be using Azure, someone is using OpenStack, etc., etc. So similarly, Azure created ARM templates, which is Azure Resource Manager templates. And then for OpenStack, we have Heat templates, right? So every cloud provider came up with an idea that let's create a infrastructure as code where developers would be able to call the cloud API and create or provision these resources. But think of it in this way. Do you think that learning all these is feasible to someone or to an organization? So organization have thousands of projects, right? And in this, someone is using AWS, someone is using Azure, OpenStack, K8, GCP. So if a DevOps engineer or to maintain, right, or to maintain an infrastructure, do you think an organization will have some engineers who have knowledge on CFT or have a mastery on CFT, the ARM templates, the heat templates, etc., etc.? So it was very difficult to get a track and learn all these things all at once. So HashiCorp is an organization, it's an org. So they saw this gap, and what they did, they created a tool called Terraform. So what Terraform did is it provided multi-cloud support, right? It was fast. It was not error prone, you will be able to version manage it, and there are n number of benefits of Terraform. So now learning Terraform makes your work easy, right? You'll be able to manage Azure resources, AWS resources, OpenStack, and any other cloud providers or any other infrastructure process. So this thing was very useful when it came into the market, and it was highly acceptable by the organization because it solved a big problem. It also narrowed the gap into the market, and the organizations were happy to accept this. And that is why Terraform is the leading industry tool where every organization is tending to use Terraform as their infrastructure as code. So, what infrastructure as code stands for? Now you understand it. That writing your code which will provision your infra. And infra means your resources, which can be your VMs, your databases, networks, or etc. Right? So now you understood what is why the Terraform was needed into the market and how it solved a big problem. So Terraform, so I'll write TF instead of Terraform, and this is a keyword for Terraform, right? So what it does, it creates resource dependency graph. Also, it compares your desired state versus current state, and it applies the changes to reach the desired state. Now let's understand how Terraform works from root level, and let's see how it basically solves the problem. So Terraform uses a declarative model. So now you will say, what is declarative, right? So to understand declarative, we should first understand imperative, right? So think of it in this way. Imperative is, for example, you created a script, a shell script. Okay. You have step 1 to define your variables. Step 2 to create the directory if it does not exist. If does not exist. Next step is you create the backup of whatever file you want to create. And step 4 is you verify your backup. So you can see clearly what is happening over here. So first step 1 is running, then step 2, then step 3, and step 4. So let's say you did not created the directory. So let's say you have defined the variables and you want to jump directly to the next step, which is step 3. And the directory does not exist. So what will happen? It will clearly throw an error that, hey, your directory does not exist where you want to create a backup and store your file. So this is the error and you need to fix it. Go and create the directory first and then come back. So in this case, what is clearly happening? It is interdependent, right? That without step 2, step 3 is not possible, and without step 3, step 4 is not possible. So this is called imperative coding or imperative graph. Now what declarative is? So Terraform uses this declarative model where what we can say is you have some desire to create an infra or provision the resource. The Terraform engine understand it and it says, okay, I will execute your plan and provision you the infra you requested. right? In this graph, what you can understand is whenever you create or whenever you go to Terraform and you describe what infrastructure should exist, so you do not define how to create it, right? So for example, you do not write the steps like create VPC, then wait, then create subnet, then wait, and then create the EC2 instance. You do not do it like that, isn't it? So what you do in your TFI, you basically go and say, hey, I want a VPC and I want a subnet inside that VPC, and then create an EC2 instance into that subnet range. You do that. What Terraform does is it automatically figures out how to create them in the correct order, right? So this is what declarative basically means. Now let's understand one more thing, which is Terraform works in three main phases, which is write, plan, and apply. Now, through a graph, we will understand how these processes are carried out. So, what you do, you go and create a TF file, right? A TF config written in HCL. HCL basically stands for HashiCorp Configuration Language. Now, your config is parsed through Terraform engine. It builds RDG, which is resource dependency graph. It compares your desire with what you have right now. And then it generates the exit plan. Okay. And then the provider plugins you have, it can be different. It can be AWS, Azure, anything. So those are called provider plugins, and it calls the cloud APIs. And then what happens? Infra is created. This is the simple flow, how from end to end you perform actions to create your infra, right? So next, what it does, Terraform communicates with cloud providers using APIs and creates the resources. So in this step, as you can see, provider plugins called cloud APIs. So how it does it, let's understand that as well, which is very important. So the example flow of the API call is you've written the TF code, right? Now you've written this in your local. Then how AWS will provision your resources? Have you ever think in this way? That have you ever thought of that? Like I've written the code now what to do? How the API call is being made? How the resources are being created, and how the cloud provider is able to resolve those code and create the resources. So Terraform code which you have written goes to the TF core, which is the parser plus the graph engine, which builds the resource dependency graph, right? And then it goes to the AWS provider plugin, which you have configured into your Terraform code. It makes a REST API call. So for example, it is HTTPS, okay, ec2.amazonaws.com. It goes there, it makes a REST API call, and your provider understand that, hey, it is making a REST API call. The provider plugin is saying, this is the code, I want something to be created, and then it creates the infra. Clear? So this is the way how the internal calls are being made. So API call. How this workflow happens and creates the infrastructure, and then you are able to see or define or manage or provision your resources into your cloud. So A very deep concept is here, which I guess you should understand, and it is very important. So, Terraform builds a resource dependency graph. As of now, you have clearly understood resource dependency graph is a very important thing, and this is the man who is the core person in Terraform, which is handling the creation of your resources. So, what it is and how the resource dependency graph resolves your Terraform code. Now, let's see. So, Terraform internally converts your configuration into a DAG. What it is? What is DAG? DAG is directed acyclic graph. You can Google it, understand the concept, what is directed acyclic graph, come back, rewatch this video, and then will clearly understand why I'm talking about that. Let's not deep dive into this topic as of now and concentrate on Terraform itself. So, DAG is a very important thing in Terraform. He's also an important man and he has some responsibility to perform and he does it very accurately. And why I'm saying this is Terraform must ensure that no resource is created before its dependency, resources run in the correct order, and maximum parallel execution should be performed. That is why Terraform uses DAG, right? So this graph determines which resource depends on which resources can run in parallel, and which resources must wait. So for an example, if you want to create a EC2 instance, will you be able to create it directly? Think of it. No, because you haven't defined the subnet configuration, the firewall rules, or security groups, or your key pair. So these are the resources which are required, right, to create your EC2 instance. So before that, let's take a very basic example. Even before creating your EC2 instance, you want subnet to be created so that you can create your EC2 instance inside this subnet range. And to your subnet range to exist or your subnet to exist, you must have VPC. Without this, it is not possible to create EC2 instance. And it will directly throw an error. It will say, hey, please go and first create subnet, then VPC, then come back and I will be creating your EC2 instance the way you want. So Terraform understands this, that VPC must be created first, then subnet depends on VPC, then EC2 can be created, right? So this is an example where you can see clearly that DAG or the resource dependency graph is able to automatically understand which resource depends on which, what is the interconnection, what is the interdependencies, and then it creates it automatically. You do not do that. You do not yourself go and say that first create the VPC, then create the subnet, then create the EC2. You don't do that, right? You just declare it, I want these things. And then it creates itself. It manages out, it figures out what has to be created first, and then it creates it. This is the way where you can understand the previous concept which I was explaining, that this is automatically handled, managed, or figured out by the Terraform. So this is a one way where it figures out the interdependencies, or which resource can wait or which resource can be created first. The next important topic inside the tag is it follows the parallel execution. Think of it in this way. You want to create a S3, right? So to create an S3, do you think you need VPC? Is VPC required to create S3? Or is subnet required to create S3? Or to your EC2 instance? No, right? These things are not required. But S3 as an individual does not require a subnet range or a VPC or EC2. So let's say you have defined these things into your Terraform configuration files and at the same time S3 as well. So let's take a basic example. S3 needs to be created. You want an S3 bucket so that you will be able to store your objects into this. So what will happen? And at the same time, you have also defined IAM to be created, IAM role, sorry, and VPC to be created. So what will happen is Terraform will do a parallel execution, and at the same time it will create these three things. This is why Terraform is very fast, because these things are not interdependent to each other, right? These are not interdependent. So Terraform does not wait for each resource to be created first and then to be next. So in this way, parallel execution is handled. So for under DAG, sorry. So under DAG, two things are taken care of: interdependencies and what? Parallel execution. So in this way, Terraform handles or manages your infra, right? So if you want to understand it from the very start, let's do a quick revise or summary of it. So first step is you write your TF files, your code, the resources you want to be created. It builds RDG, resource dependency graph. It reads the state file. We'll come to this topic later, but for now, understand it. State file is very important and it is required. You compare desired state versus current state. Now generate your exit plan or execution plan, and then send action to provider. In our case, it's AWS, right? And then what provider does? It make API call to the cloud, and your infra is created. So this was basically how Terraform works. So all these concepts which you see over here is how Terraform works. Internally, the deep concepts, the DAG, the resource dependency graph, how the API call is made, and then how these three phases are carried out: write, plan, and apply. And also the most important, what is declarative versus imperative. So now you understood, and now you know it very clearly that what is declarative and what is imperative. So let's move to the next topic, which is why we use Terraform. The question is why we use Terraform, right? So first is infra automation, right? So Terraform solves several major infrastructure problems. One of it is, without Terraform, what you would have done? You would have gone to or log into console, AWS console, create VPC, and then create the subnet, then instance, and these all things will be taken care by manual process, which is slow and error prone. So this thing is resolved by Terraform. Second is infra consistency. What does this mean? Infra consistency. Now, without AAC, you have multiple environments, right? Dev, test, stage. And this is where what Terraform resolved. So this was the biggest problem, where in a project there are multiple pipelines or multiple environments, right? And in each environment, you have your infra. In each environment, you have your infra. It is very difficult to manage it manually. The process will be slow. You will face a lot of errors. For example, I am creating an infra in dev and someone else is creating in test, and there are high chances of making a mistake by provisioning these resources. So what will happen? Your pipelines will fail, and then you'll be in a big trouble. That is why infra consistency is what managed by Terraform, and you can apply these changes to all these stages all at once, right? And it what it does, it reduces it. So you will come across this topic or this word quite often in Terraform, which is environment drift. So it does not creates the environment drift, rather it resolves it. Next step is version control. You can push your repository to GitHub, which will what it will do? It will track the changes. It will audit your infra. You'll be able to audit your infra, and you can make a rollback whenever you do some mistakes, right? Reproducibility, the most important thing which I found in Terraform and is and often ignored is you have a concept of modules, which we'll cover later. The modules are highly beneficial for your resources to be reused. It can be S3, anything. So these resources can be mimicked into multiple environments, and you have to write it once only, and in this way you'll be able to reproduce or reuse your modules, right? Then we have scalability. Scalability is one of the topic where if you want, let's say if you want uh, 10 EC2 instances, right? So will you create it one by one? No, right? Will not create it. So you have a resource block, and what you do is you just add a variable count equals to 10, and it will create 10 resources all at once. So we will come across this count or variables, other things, what are the functions and other aspects of Terraform, and we will understand this later. But for now, just understand scalability is one of the major challenge which Terraform resolved. Multi-cloud management. As of now, you must have understood it very clearly that how Terraform manages multi-cloud. So let's say in an organization, in AWS, you have your compute. For storage, you use Azure, right? And for analytics, you are using GCP. So these all things can be collectively handled by Terraform all at once. So single tool manages everything, which was not possible when everyone introduced their own templatization model, right? OpenStack for heat, and this had CFT, this had ARM, OpenStack had heat. So this was not possible at all to learn each and every language. Now, seventh point where we can understand why we use Terraform is dependency management. And this is now very clear to each and every one of you that dependency management is handled through RDG, DAG, and how beneficial it is. Eighth is cost optimization. This is also very important. Let's say in your infrastructure, some of the EC2 instances are not working or stopped, or you do not need them. So in that case, the unused servers or unused instances can be detected, and it can be destroyed easily, right? Or if you wanted to reapply, it's fine. You can reapply that as well. One of the other important point which I feel is um, failovers. Failovers. Let's say in a region US US East 1. So nowadays you must have seen that Middle East war is going on, the US East region was down, something like that. So let's say your infra is in US East 1, and due to some reasons or due to some calamities or natural disasters or anything, your infra is down in US East 1. What you will do is your infra code is present in GitHub. You can anytime reapply your configuration to some other availability zone, some other region as well. It can be any region, Asia, Pacific, or anything. So in this way, you will be able to understand or recreate or reapply your infra to the region failures. Right. So for now, we have understood a lot of points why we use Terraform, what what challenges it solves. These are the points. So I'll be creating a notes of it. I will put it as readme.md, or inside each and every day lecture I will create a folder structure into my GitHub repository, and I'll add all of these resources, whatever we have understood as of now, the lecture notes, and you can go through it, revise it, and then understand it. If you want to come back and watch this video, then watch this again and again, and then you'll be able to easily understand the deep concepts of Terra. Now the thing is sorry, when we use Terraform. So as of now, we have clearly understood when we use it in enterprise companies, IT companies. It can be any of the company, right? There are several real world scenarios. Uh, can be used for cloud infra provisioning, right? You can also do the DevOps automation over here. What it means, you can create a pipeline which checks out your code in GitHub, builds your infra, apply it, which means deploy your infra. You can deploy your application over there, deploy app, and in this way you can create a pipeline and automate your infra provisioning. Right. Third is multi-environment setup. So there's a concept in Terraform called workspaces, which we will cover in the later videos, and you can have multi-environment setup through that, and which is dev, test, and other. Four is disaster recovery. I've explained it before, how company manages it and how you can reapply your changes or infra to any of the region failovers, right? And at the enterprise level, you have very large scale infra that you have millions or even thousands of projects. This can be covered as well through that, and it is very easy to manage this using Terraform. It is also using platform engineering, right? And you can also standardize your infra like VPC module or EKS module or database module in this way, right? So you have to understand this very clearly that Terraform is a wide use tool accepted by the industry, very popular, and also it is very useful. So the platform engineers, the DevOps, the SREs, uh, the cloud engineers. So Terraform is useful to all of these fields. I may be missing some of them, but these are the one which I can think of right now. And it is very, very important. So to understand this, you need to understand all of this, because why I've explained this, even some of the videos on YouTube present right now do not explain all of these concepts. They do not deep dive. Do you know why? Because whenever you are creating your infra, it is highly secured. It should be highly secured. The error should not be, that it cost you a big, and it puts you in a big trouble, right? And it also come up with a cost whenever you are creating an infra, right? And the architecture is very important to understand. If you fail something, for example, in some of the security group, you opened a firewall rule, then what will happen? You will get a compliance audit, and an escalation can be onto you for opening the firewall rule, and it can breach your infra. And what it will do is there will be thousands of security concerns. You may go under attack. Your infra may go under attack, and it can cause a lot of problems. So that is why each and every step was very important for you to understand. When you do the init, when you do the plan, when you apply, each and everything or destroy was very important. And these things, how it works to the root, I've explained it. In the next video, I will explain init, plan, apply, and destroy, but with an example, so that you will be able to see live what is happening under the hood, right? So what init will do to your code, what plan will do, what apply will do, and what destroy will do. So we'll be able to see it live, because when I will run Terraform init, I will show you the internal working of it. So in this way, you will be able to understand that how crucial it is that we know the core concepts of Terraform and we do not make mistakes. We need to understand the core concepts, and we will meet in the next video. Before that, whatever the prerequisites I have mentioned, please get it done. And just understand all the core concepts, go through the documentation, go through the video again and again, rewatch it, and deep dive into all the concepts which I have explained. So subscribe to my channel for more of these videos, and see you in the next video.